Hi friends. This is once again I'm bringing you back to my channel for NEET 3. NEET 3 A level has two parts. One is content part, another one is MCQ part and detailed answers. So those who want to do MCQ, they must see my part 1 of 3, and then you have to come back to this channel. In part 1 I explained all the things about these topics: refraction of light, apparent depth, total internal reflection. Some part I explained. After that I am going to explain here 3. Then we will have MCQ questions and detailed answers for your understanding level. To check your understanding level for your NEET practice. This is for basic NEET A level students only. Refraction, I told you the light will go like this, and it will come back. That already completed. Next, laws I told you, Snell's law. These are the 4 points you have to remember. Principle of reversibility, which I explained in the previous one. Then the slab, refraction through slab, and lateral displacement, and then two applications. If you view from the rarer medium, if you view from the denser medium, then one can see the objects, how they will change their distances. That is in apparent depth and real depth relation with the refractive index that I have given you already. And quickly we will go to total internal reflection. What is total internal reflection? When a light goes from one medium to another medium, it bends. But in total internal reflection, it will go from denser medium to rarer medium. Then only total internal reflection will take place. So this you can see here, the straight light which will be enter from denser to rarer without deviation. Second ray which will be bending, most of the light will get refracted, a little light will get reflected. Then third line, if you see, it will bend towards the surface of rarer medium. Then fourth one, it is almost all grazing between the two medias. When you draw a normal, you can see that refracted angle is 90 degrees, incident angle inside the denser medium is called critical angle. So one question, surely it will come, the relation between refractive index and critical angle. And the second question is going to come, what is critical angle? So critical angle is the angle of incidence in the denser medium for which refracted angle is 90 degrees. After this critical angle, the ray which is coming from the object, it will not go to rarer medium, it will bend in the same medium of denser. So optical denser medium. This phenomena of bending into the same medium is called total internal reflection. Once again आप देख लीजिए, ये देखिए light when it is goes, it will be straight, then first light, second light, third light, then here critical angle will come, then total internal reflection. This was missing in the previous video. So now critical angle and lot of applications. Two conditions as I told you. One is incident ray must come optical denser medium, and angle of incidence must be greater than critical angle. Then here is some important relation, that is relation between the critical angle and refractive index. So you know, as usual, sin I and sin 90 will be taken as 1. So refractive index glass to air is 1. Now air to glass if you want, or air to another medium, denser medium if you want, it is a reciprocal which you know. So here is some important data is given. Substances, water, crown glass, dense and diamond. And refractive index one should know. Refractive index of water 1.33, at least you remember 1.3, its critical angle is 48. Crown glass 1.5, its critical angle is 41. And diamond, you see that 1.62 refractive index. Because of high refractive index, it has a critical angle is very less. So once light entered into the denser medium, due to the sharp faces, it will not allow to come out look like bright light and sparkling. That is why the diamond 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 will be generally is 24 degrees. So the total internal reflection take place in diamond much more times than flint glass. So diamond is very less. This data will be asked in the examination. One should remember this is from NCERT book. So other things, application, mirage, which I told you in the previous diagram. Second, looming, that sea can be, that fish can be, ship can be seen after crossing the curved surface. And then total, total reflecting prisms, that also I told you, optical fiber, then sparkling of diamond. Just now I told you because of total internal reflection. These are the applications of total internal reflection. One can see here, first application mirage. One can see in hot summer days that reflection of a tall tree looks like in mirror. Here is 90 degrees shift, here is 180 degrees shift, and here is again 180 degrees shift of the different prisms, and this is fiber optics. Then spherical surface, which I told you already, spherical surface means either it is convex surface or concave surface. And here we have that the principal axis, P is pole, C is the center of curvature, and here one is right side, another is left side. So minus and plus as per Cartesian sign conventions or new Cartesian sign conventions. This already I discussed in the previous videos. The same thing for the curved surfaces for refraction also. So incident rays taken from left to right, all measurements done from the pole. Left side measurements are negative, right side measurements are positive. And above the principal axis is positive, below the principal axis is negative. So these are the things which are not covered. I just covering. Now let us start some 12 questions to check your content.
Let's create 12 multiple choice questions, MCQs, based on the topics listed in the image. Topics 1. Apparent depth of a liquid. 2. Total internal reflection. 3. Refraction at spherical surfaces. Introduction. 4. Assumptions and sign conventions. MCQ questions and detailed answers. 1. Apparent depth of a liquid. Question 1. A coin is placed at the bottom of a container filled with water. Refractive index equals 4/3. If the real depth of the water is 12 centimeters, what is the apparent depth of the coin? A. 9 centimeters. B. 16 centimeters. C. 12 centimeters. D. 15 centimeters. Answer. A. 9 centimeters. Detailed explanation. Formula. Apparent depth equals real depth refractive index. Calculation. Apparent depth equals 12 centimeters, 4/3 equals 12 centimeters, asterisk, 3/4 equals 9 centimeters. Question 2. The apparent depth of an object in a liquid is always A. Greater than the real depth, B. Less than the real depth, C. Equal to the real depth, D. Depends on the angle of observation. Answer. B. Less than the real depth. Detailed explanation. Due to refraction, light rays bend away from the normal as they exit the liquid, making the object appear closer to the surface than it actually is. 2. Total internal reflection. Question 3. Total internal reflection occurs when A. Light travels from a rarer to a denser medium. B. Light travels from a denser to a rarer medium, and the angle of incidence exceeds the critical angle. C. Light travels from a denser to a rarer medium at any angle. D. Light travels from a rarer to a denser medium at any angle. Answer. B. Light travels from a denser to a rarer medium, and the angle of incidence exceeds the critical angle. Detailed explanation. Total internal reflection requires light to move from a higher refractive index medium to a lower one, and the angle of incidence must be greater than the critical angle for that interface. Question 4. The critical angle for a glass air interface is 42 degrees. If a ray of light in glass is incident on the interface at an angle of 45 degrees, what happens? A. The ray refracts into air. B. The ray is partially reflected and partially refracted. C. The ray undergoes total internal reflection. D. The ray is absorbed. Answer C. The ray undergoes total internal reflection. Detailed explanation. Since the angle of incidence, 45 degrees, is greater than the critical angle, 42 degrees, total internal reflection occurs. 3. Refraction at spherical surfaces. Introduction. Question 5. Refraction at a spherical surface occurs because A. The surface is curved. B. The refractive indices of the two media are different. C. Both A and B. Or D. The incident light is monochromatic. Answer C. Both A and B. Detailed explanation. The curvature of the surface and the difference in refractive indices between the two media cause light rays to bend as they pass through the surface. Question 6. Which of the following is not a common type of spherical refracting surface? A. Convex surface. B. Concave surface. C. Plane surface. D. All of the above are common. Answer C. Plane surface. Detailed explanation. Plane surfaces do not cause refraction in the same way as curved spherical surfaces. They cause refraction, but not in the context of spherical surfaces. 4. Assumptions and sign conventions. Question 7. In the derivation of the refraction formula for spherical surfaces, which of the following is a common assumption? A. The object is far from the surface. B. The aperture of the surface is large. C. The rays are paraxial, close to the principal axis. D. The refractive indices of the media are equal. Answer C. The rays are paraxial, close to the principal axis. Detailed explanation. Paraxial rays simplify the derivation by allowing the use of approximations like sine theta approximately equals theta and tan theta approximately equals theta. Question 8. According to the Cartesian sign convention, distances measured in the direction of incident light are A. Negative. B. Positive. C. 0. D. Dependent on the medium. Answer B. Positive. Detailed explanation. The Cartesian sign convention dictates that distances measured in the direction of incident light are positive, while those measured opposite to the direction of incident light are negative. Question 9. In the Cartesian sign convention, the radius of curvature of a concave surface is A. Negative. B. Positive. C. 0. D. Depends on the object distance. Answer A. Negative. Detailed explanation. For a concave surface, the center of curvature is on the same side as the incident light, making the radius of curvature negative, according to the Cartesian sign convention. Question 10. The height of an object above the principal axis is considered A. Positive. B. Negative. C. 0. D. Depends on the object's position. Answer A. Positive. Detailed explanation. Heights above the principal axis are considered positive, while heights below are considered negative. Question 11. The focal length of a convex refracting surface is A. Positive. B. Negative. C. 0. D. Depends on the object distance. Answer A. Positive. Detailed explanation. Convex refracting surfaces converge light rays, leading to a positive focal length. Question 12. The focal length of a concave refracting surface is A. Positive. B. Negative. C. 0. D. Depends on the object distance. Answer B. Negative. Detailed explanation. Concave refracting surfaces diverge light rays, leading to a negative focal length. Let me know if you would like any adjustments.
All YouTube viewers of my channel request you to go through slowly one by one by stopping my video continuity. Check the end of the content and learn the concept which will help you in your second senior secondary and for NEET exam A level students. Next, NEET A level students, I am giving you some numerical questions on this. So please see my videos and like them if the content is good. Thank you for watching my video.